The following is a presentation of the Industrial Innovation Digital Features project titled Towards Safe Smart Construction, Algorithms, Digital Twins and Infrastructures, presented by the Distributed Hybrid Systems Group at KTH Royal Institute of Technology. The project team is composed of academic and industrial partners, with three different schools at KTH represented: the School of Electrical Engineering and Computer Science, the School of Architecture and the Built Environment, and the School of Industrial Engineering and Management. Industry-wise, the project is represented by the companies Skanska, mainly focused on the construction part, and Ericsson, for the networking infrastructure and services. To give some context to the project, construction sites nowadays have high carbon emissions, are not very sustainable, and require extensive manual intervention, which implies safety risk and complicates the task of quality control. Additionally, being mostly manual labor with a low degree of automation means that real-time monitoring is difficult to achieve, and therefore the production cycle is slowed down. This project aims to fully digitalize and automate the construction process based on the Skanska use case to produce reinforcement cages on site through a multi-system setup. These cages are then filled with concrete and are used for the construction of different infrastructure projects, like bridges and tunnels. This multi-system setup is based on two subsystems, A and B, to produce the cages, and subsystem C to place them on site. These subsystems are then controlled and monitored by three modules or work packages that bring together the automation and digitalization to the subsystems. These three modules will advance the state-of-the-art in smart construction thanks to the creation of a digital twin coupled with a real system, an optimized networked infrastructure service tailored to the use case, and a heterogeneous multi-robot task planning and control that considers spatio-temporal constraints. This in turn will allow us to achieve the goals of the project, not only for the Skanska use case, but also for understanding 5G and B5G systems, and finally develop the consortium and attract more funding in the area. As I explained before, the project is composed of three work packages, which will then be complemented by an extra one where all the developed technologies will come together for the Skanska use case scenario. Work package 1 is based on creating the models for the digital twin and collect sensor and command data to visualize the system and support the decision process. This will be done through data analytics combined with AI algorithms, which will allow the prediction of the system behavior and effectively remote real-time monitoring and control of the robots. Work package 2 is based on the optimization and prediction of the networked infrastructure towards 5G and B5G networks. This will leverage the digital twins and other techniques to optimally support communication and computational demands. With all of this, an adaptable interface will be developed that allows the application for the smart construction case. Work package 3 focuses on the control and task planning. Novel methods for user-friendly and control-oriented planning will be developed through the use of formal verification languages that allow to consider different types of constraints for the system, including communication constraints between heterogeneous platforms. Additionally, to enhance these methods, data-driven and learning-based methods for optimal control will be used to enable efficient and high-performing control online in the complex system of subsystems of this project. Lastly, Work Package 4 will incorporate the previous three modules to prove the applicability of the research developed. For this, the digital twins of the three subsystems, A, B, and C, together with the networked infrastructure from Work Package 2, and the developments in the control and planning from Work Package 3, will be joined together to conduct a demo demonstrating the fulfillment of all the different milestones and objectives for the project. With this, the presentation is finished. I hope you enjoyed and thank you for listening.